Today we're talking about equations of lines in three-dimensional space. This is from section 9.5. We're going to start out talking about parametric equations, which means that we have an extra variable in there, t, which is the parameter. So for an equation of a line in three-dimensional space, we need a point that the line goes through, and we need a vector that gives us the direction of the line. If we want to write this equation as a vector equation, all we do is use the position vector of the point. So we turn it from a point into a vector. That's r0. And then we have our direction vector, v, and that vector just needs to be parallel to the line that we want. So we can write this vector equation as r equals r0 plus tv. If we want to write this in component form, then we can think of r as being x, y, z, r0 as x0, y0, z0, and v as a, b, c. So here's our vector equation in component form. We have x, y, z equals these three components. So really we're just adding the two vectors, the position vector of the point and t times the direction vector. Now if we want to write this as scalar equations, we can split this up into the three components. So we end up with three equations. We'd have x equals x0 plus ta, y equals y0 plus tb, and z equals z0 plus tc. Okay, let's look at an example, and we'll look at it on our Maple applet so that we can see what's actually happening when we do this in space. Okay, so we're going to find parametric equations for a line that goes through the point 2, 3, 5, parallel to the vector 3, negative 1, 4. Okay, so we're putting in our point is 2, 3, 5, and our direction vector is 3, negative 1, 4. And in this applet, we're going to do advanced operations straight line. Okay, so here's what the situation looks like. Notice it draws the line for us in green. It's going through our point 2, 3, 5, and notice how it's parallel to our direction vector over here. You can see this better if you move this around a little bit. So the line and the vector are going in the same direction. Now if we want the equations of that, all we're going to do is take we can do either a vector equation or we can do scalar equations. Either way, all we're doing is taking the x component of the point plus t times the x component of the direction vector. That's our x component in our vector equation, or it's equal to x in our scalar equations. We do the same thing for y, and we do the same thing for v. So it's always the coordinate from the point plus t times the coordinate from the direction vector. So here's our vector equation, and this would be our set of scalar equations.